smashing pumpkins. It's not quite Halloween yet, but I get that little Halloween feel. Gonna smash some pumpkins. That'll be a story for a different day in psychology, probably. But we are going to talk a little bit about things that create people to act violently over the next couple lessons. We'll tie in there. Kill the music. All right. Topic of today's lesson is on psychological experimentation, specifically the design of a good psychological experimentation. Our last few lessons have really been geared towards hopefully getting you to understand that psychology is in fact a science, and there's a lot of empirical thinking that needs to occur when addressing the issues that psychology brings up. So, with today's lesson, let's talk about how to design a good psychological experiment. The first place that we need to start is when picking people to participate in a psychological experiment, you have to have initial equivalence. Oh, I'm going to have to check my spelling on that one. I don't know about that A there, kids. Yeah, I don't know. I'm going to let it go right now. I'm balking at it, not sure. Remind me to look that up someday. Initial equivalence, right? So the idea of initial equivalence is that group that you have participating in the psychological experiment has to have some level of consistency, right? Some level of consistency. I'll give you a couple examples, right? If there is not consistency, we're going to address that as the confound. And so a group participating in an experiment, let's say we were to run an experiment and I've got ages ranging from like 7-year-olds to 49-year-olds. That wouldn't seem to make a lot of sense, right? Because it's going to throw off our ability to measure things in some sort of a way where we can't just chalk up the differences to age. Okay? So that might be a great example right there. If the percentages of differences, so just as an example, right? If we're to do ages 7 to 49 in our experiment, this would be confound, right? This would not be sort of logically appropriate because then the differences, right? Any potential findings could be chalked up to age. Similarly, let's say we're going to run an experiment where we're going to have kids play violent video games, right? And notice I use the word kids. If we were to do ages 7 to 49, you might be like, oh, well, adults are going to be more capable of understanding that video games aren't real life, and we could just chalk up any finding perhaps to age because of the confound variable there. But let's do another example also where the confound might become important. What if we said, all right, we're going to run an experiment, but this time we're going to have like a sort of weird confound variable where certain percentages, 80% of the people that we have play these video games already know how to play video games and have played video games before. Right, so 80% of the people participating in the study might already know how to do something, and 20%, right, do not know how to do something. Well, now you might be able to go, well, this is not going to be a fair experiment because the confound variable between those people who know already how to play video games and those who don't, that might be too extreme, right? The spread between 80% to 20% might be too extreme. Whereas we could probably design something with a little bit less confound variable than that. So that's sort of the first thought when you go to design an experiment is, are you recreating confound variables that are going to be chalked up, any potential findings chalked up to like a mistake in the design of the experiment to begin with. On the other hand, right, so the opposite of confound variables would be like control variables, right? Control variables and control constants. So for instance, let's just kind of run the opposite. If I were to design an experiment and just as a control constant, we're going to say we're only going to look at 7-year-olds. Right now, I have the ability to like draw real conclusions about what 7-year-olds may, or how 7-year-olds may react when they encounter violent video games. If that's the experiment that I'm designing, just sort of, thinking of one off the top of my head there. So that would be a control constant. We're going to work with all kids of the same age group. Another possibility would be like this sort of control. Instead of a confound variable, we're going to do a control variable. Okay, and this time we're going to keep this percentage a lot more equivalent. Rather than a big spread in the percentage of like 80-20, maybe the control variable will just be simply that like we're trying to get close to 50-50 as possible, or we'll have separate groups and each group has to have the same sort of variable spread where you have even different groups within the group. That might be something like 60% already know how to do something. Right, and 40%, you're gonna like squeeze that percentage sort of control variable together, so that way you can draw more consistent conclusions about whatever it is you're trying to learn about. Right, so that's the first thing: is this idea of initial equivalence, designing an experiment. One way that you might create initial equivalence is perhaps through a survey. Make sure that's on the screen there. I'm working over there, right? You're going to design a survey, right? And a survey might find that like 60% of your participants know how to do a certain something, right? The other 40% not so much. But if I were to give a survey and find out that I've got a big, confound variable, a big spread between what creates these participants to be somewhat equal, then I might go, well, geez, I can't really use that group. Right, so if I survey my participants ahead of time, then I can select participants in the actual experiment that are going to be somewhat similar. So that way the conclusions that I'm drawing, we can really chalk up to the variables, which we'll get to here in a second, the variables that the experiment is meant to change rather than some other things that are outside of our control, like more of these confound stuff. Okay. So let's fire off an experiment here based on this information. And I'm going to have to come on over here. We'll shift the board over a little bit. Okay, so let's design a quick little experiment. We're going to take 7-year-olds, right? And 60% of the 7-year-olds are already familiar with how to play video games. So we're kind of dealing with a pretty tight margin there, and the other 40% are not, but that kind of like tightens our focus on what we need to do. And then we are going to randomly assign, and that is big here, a random assignment of our participants. So once I have my participant group and I say most of my participants are roughly the same, then we have sort of like controlled the participant group, if you want to think of it like that. And now we're going to take these sort of controlled participants and we're going to funnel them into 2 separate groups, right? And they will be randomly assigned into group A and group B. And now we have the ability to affect these 2 groups a little differently, right? And this is now where we can, as in the matter of psychological design, we can actually change a variable on purpose in order to observe any behavioral changes. And because we have done a good job of controlling the group that the participants are chosen from, we can then perhaps ascertain some like real thoughts as the behavior patterns. So let's say group A is going to be exposed to very violent video games, which I'm just going to abbreviate as VVG. Very violent video games, VVG. And so Group A is going to play very violent video games. And Group B, they're not going to play very violent video games. They're going to do a non-violent video games, NVVG, non-violent video games. And then once these two groups have been exposed to the different violence levels in video games, then we can observe their behavior. And of course, we'll probably design some sort of a game afterwards that measures how violent these two different groups, or the participants of these two different groups, act towards an opponent in some other competitive game after this. And we'll measure whether those that were exposed to the very violent video games somehow become more aggressive because of that exposure to the video game. So coming out of these two sort of variable switch groups, they're going to feed back in, and they will participate in some sort of like an exit test, if you want to think of it like that, a common activity, which will then allow us to measure exactly what we were trying to measure in the first place. So the most common example of a common activity would be, you would take these participants, you would have them engage in some sort of like a little game activity where perhaps they could deliver a shock or do something that is punishing towards an opponent. And the experiment would measure whether the people coming out of Group A therefore sometimes become more aggressive in this sort of exit common activity than the people coming out of Group B who are not exposed to any type of violent video games. So this would be sort of the basic creation, again, just using the violent video game one as an example. This would be sort of the thought process that has to go into designing a proper psychological experiment that's going to measure what we want it to and take into consideration the participants so that when we do get a measurement, we can really attribute it to these sort of changes in the variable that the experimenter wanted to control and not some of this other stuff that was outside of the control of the experimenter.